Hello everyone. In last lecture, we have seen the internal block diagram of 8054 IC. Have a quick revision of the architecture of this IC. Basically, this consists of three counters: counter 0, counter 1, and counter 2. And all these counters work independently but have similar type of organization. And there is a one data bus buffer that is connected to internal bus and the data lines D0 to D7. There is a read-write logic which have different signals, different inputs, such as write, read, A0, A1, CS. CS is chip select. This is active low signal and used to enable this 8254 IC. And these two pins, A0 and A1, this is address line, and this address line is used to select any one counter or control word register. So in next slide, we will see how this A0 and A1 is used for the selection of counter. Through this A1 and A0, this is 2-bit. And with this 2-bit, there 4 combinations are possible: 00, 01, 10, and 11. If both input are 00, then the counter 0 will be selected. And if 01, then counter 1 is selected. If 10, then counter 2 is selected. And if the value of A0 and A1 bit is 1, then control word will be selected. Now, next, we will see how this control word will be formed. So, this control word consists of 8-bit from D0 to D7. Basically, this control word is generated by control word register, and this register is of 8-bit, and the value written in this blocks or in this control word will decide the mode of operation of this 8254 IC. So one by one we will take the bit number and discuss its detail. So first, D0 bit. If this is LSB, least significant bit, and this is the MSB, that is most significant bit. Now, if the value of this D0 bit, this is single bit, D0 is a single bit. It have either 0 value or 1 value. Only 2 values are possible for this D0 bit. So, if programmer or user will write 0 or program this bit as a 0, then this timer, this 8254 timer IC will work in binary mode. And if this D0 bit is 1, then in which mode it will work? In BCD mode. So for 0, if D0 bit is 0, then this 8254 timer will work in binary mode. And if this D0 bit is 1, then this 8254 IC will work in BCD. And now next 3 bits, D1, D2 and D3 together decide the mode of operation. In first video, we have discussed that 8254 timer IC will work in 6 different modes. So, by the value of these 3 bits, that is D1, D2 and D3, we will decide the mode of operation of this 8254 timer. So with these three bits, these are the possible combination. We have three bits D1, D2, D3. So if all three bits are 0, who will set this the value of this bit? User. So if the value of all these D1, D2, D3 is 0, then 8254 timer will work in mode 0. Mode 0 is named as interrupt on terminal count. We will discuss these modes separately in detail with the timing diagram, clock signal, out signal, and gate signal. But here, just we are observing the mode based on the value written in these three bits D1, D2, and D3. If 000, then mode 0. If 001, then mode 1. This crosses, don't care. 10, then mode 2. 11, then mode 3. 100, then mode 4. And 101 is mode 5. So this is decided by these three bits D1, D2, and D3. So first bit decide the mode, binary or BCD mode. Next three bits decide the mode of operation. Now next two bits D4 and D5. Read, write 0, read, write 1. So if these two values are 0, D4 and D5, then counter latch command 01, then read write LSB byte only, 10, read write MSB byte only, 11, and so on. And the last one is counter section. This one, select counter. D6 and D7 bits decide the counter number. So D7 is SC1 and D6 is SC2. If the value is 00, counter 0 will be selected. If the value is 01, then counter 1 will be selected. If the value is 10, then counter 2 is selected. If the value is 11, then this is read back command. Means on the basis of what we can say? On the basis of values written over here. The counter number, mode, operating mode, binary mode, BCD mode, read command, write command. All these things can be governed. So, these D0 to D7 bit, who will decide? This is according to the requirement. If you want to connect your processor with this counter 0, I am giving you question. What is the question? If you have to interface your microprocessor with counter 0, then what you will do? You will write 00 value in this D7 and D6 position. And if you want to operate your counter in mode 0, then what you will write? You will write 000 in the position of D1, D2, and D3. Now again, if you want that your counter and timer will work in binary mode, again you will write 0 over here. And if you want to read only LSB byte, then you will write 0, 1 over here. So now next, what will be the pattern? Pattern is 0, 0, 0, 1, 0, 0, 0, and 0. So this is the control word format. And what is the hexadecimal value of this? This is the control word format. What is the hexadecimal value of this binary? This is 10H. So what is the control word for this given problem? 10H. So while interfacing, the user, while writing ALP program, upload this value 10H. So when we discuss interfacing circuit in class, then we will discuss in detail how to frame different control words and how to write these control word for any application. Till now, till then, you have to go through this control word format and try to frame different control words for different kinds of situation. And in next video, we will see some more details. Thank you. Have a nice day.